Mahesh Kumar Reddy. My name is Mahesh Kumar Reddy. I am E2 ECE department. The control processing units in 1950s are of that much size, and now they are reduced to the microprocessors are of this size. In doing so, the problem we are facing is that the amount of heat that is produced on a chip, it is destroying the metal linkages between the electronic devices. So we have to choose a metal such that it has high electrical conductivity and high thermal conductivity. That is nothing but the copper. But nowadays what we are using in ICC is that we are using aluminum as a principal conductor. Why? Because the present machining techniques of copper are toxic. In order to machine the copper, we have to use ferrichloride to machine copper, but it is a very toxic in nature. So generally the electronic companies nowadays, they are going for aluminum instead of copper. So but we are losing the usefulness of copper. If we can use copper instead of aluminum, we can increase the microprocess speed by 20%. So here comes how to machine copper. In 2005, there is a scientist called Daniel Johnson. He has taken a bacteria called Acetothiobacillus ferroxidans to cut the copper. This is the bacteria Acetothiobacillus ferroxidans. You can see over there. It has it converts Fe+2 ions into Fe+3 ions as a part of its energy producing cycle. The reaction 2Fe+2 plus half O2 plus 2 H plus ions gives us to Fe+3 ions. These Fe+3 ions are if the copper metal is reacted with that ferric ions, they will be converted to Cu2 plus, which is nothing but the oxidation of copper. Oxidation of copper is just like the removal of copper, because in rusting it's nothing but the rusting of copper. So we are removing the copper using a bacteria. This is the experiment. You can see over there the lines which are these are the black lines which are not exposed to bacteria, and these are the white lines that are exposed to bacteria. These white lines are the amount of these white lines are removed, and there is a depth of cut over here. So you can see that we can use a bacteria to cut the copper metal. And this image, you can see there are some irregularities over the surface, and there is a surface finish, soft surface finish after machining, after conducting the experiment. So what we can conclude is that if we can develop this procedure, biomachining of copper, to machine the copper, you can increase the microprocess speed by 20%.
Good. What's your ambition?
My ambition is to become a scientist in embedded systems and microcontrollers.